Yo, guys.
All right, the quantum computer video. This one was a lot of fun to do. This one was crazy fun, but it took a minute. I love this meme right here. Is this Minecraft? Is this Minecraft? Is this mine? This one took a minute. This one took a while to do. In fact, now that I think about it, the last video, the Infinite Staircase, was released because of how long this video took to make. I was supposed to put up that video for that month, but it took too long, so I had to last minute come up with Infinite Staircase. I just remember that. But yeah, this one, it was a lot of fun. Took a while. It was a collaboration with IBM, which they didn't say this, but I think they're not too happy with this video.
It makes sense to me, man. They've open sourced
yeah.
quantum computers.
I'm not going to get too deep into that, but that's just my feeling on the results of the campaign. But I think it's a great video.
Qiskit, lead on. But to get started with today's project, I'm gonna first.
Yeah, so this one I had wanted to do something on
how can I expect to be able to understand how to program for a quantum
the wave function collapse algorithm for quite a minute.
I should probably explain what Qiskit is.
And then IBM's team, the Qiskit team, came and wanted to do a video based on the quantum computers. And at the time, I didn't know really anything at all about quantum computers. I just knew that the wave function collapse algorithm that's demonstrated later in this video was inspired by quantum physics. So I thought it was the perfect fit. But as the video will divulge a bit later, it wasn't really a good fit. We'll get into that a bit later.
Qiskit has an amazing UI that helps make writing quantum algorithms really simple.
Yeah, I was quite surprised at how fun writing quantum algorithms was, even though I still don't really understand it and it's still really difficult because it's like four-dimensional mathematical rotation that you're doing to qubits, and it's like really complicated, but it's a fun challenge. I still haven't returned back to like try and do more with it yet, but I mean I have like the basics of it down at the moment. So if I ever need to apply that knowledge later, then. But at the moment where I'm at is I much rather wait for the researchers to like create like basic algorithms within quantum computing, so that I can then use those basic algorithms as building blocks to create like even more stuff, versus me trying to like figure out the math to how do you do like an AND operation, for example.
Particle wave. Okay. All right. Fine. I'll do my research. Okay. All right. We're now about 3 weeks in, and I still really haven't done.
Yeah, this video was really interesting because like I had the whole idea planned out and how it was going to unfold before I started to do this research. And then I started to do the research, and I started to quickly realize that what I wanted to do is not going to happen. And so I had to make like so many different pivots as I learned more and more about quantum computing. One thing that I didn't realize is how like early it still is, the research still is. I thought that I would at least be able to use a quantum computer to do something, like really anything that you would be interested to watch and learn about. But at the time making this video, that was not the case.
And they only will place a house on the terrain if
so this was the pivot. The idea was to involve more of the wave function collapse and kind of talk about like traditional generation, procedural generation at the moment, and how wave function collapse could change all of that. But the problem with wave function collapse is that it's quite slow in most applications. So I then kind of take that premise and like propose like what if quantum computers allow us to use algorithms like this to speed up generations and have our procedural generation have a lot more fidelity.
With a quantum computer, trying to figure out how to write a quantum program to generate like this may be
funny thing about this demo right here that you're seeing on screen is I actually wrote this demo like a year or two ago, and it just laid dormant on my computer, and I just dusted off and used it for this. So that came in clutch versus having to write it from scratch or finding someone else's repo, which wouldn't have been hard. This right here was added at the very last minute, like right before I was about to release. Dr. Wooten, James Wooten, wrote a paper on quantum procedural generation, which I still don't fully understand, but from what I do know, it's quite huge.
In which the terrain, plants, houses, buildings, roads, you name it.
It's just a matter of like being able to use a quantum computer to actually calculate that generation algorithm that he used, or that he discovered or invented. I don't know. Is it discovered? Is it invented? I don't know.
Very magical generation algorithm called the wave function collapse algorithm, created by a computer scientist named Maxim Guman in 2000.
Yeah, I still love this algorithm, dude. I love this algorithm so much. And you can see how long it takes. That's just like a 2D image with a resolution of like maybe 16 by like 30 or something like that, and it still takes a minute. So you can imagine popping that out with an extra dimension, 3 dimensions, and then increasing the width, length, and depth. It takes quite a minute. But I do think that I could have sped up the generation time that my algorithm was spitting out if I would have just optimized the rendering. I didn't optimize rendering whatsoever, so I think that's where a lot of the latency comes from with generating maps with my algorithm.
In this example, it's only 3: the dirt state, grass state.
Yeah, this video is so fun. Like, I went all out on the editing. Like, when the music is like on point, that's when you know like I'm really into the edit.
Must have a dirt state under it, and must have another grass state on every side of it. And when we give rules to all of our states and tell it to generate,
still, this is so fun to watch. This is so fun to watch.
Which then will make
like, it will always be fun to watch like a map materialize right before your eyes.
This keeps on going until all positions on the map have exactly one possible.
It's so satisfying.
Voila!
It's so satisfying. It's just following your rules, rule set. It's so satisfying.
This algorithm doesn't become actual magic until you have a giant list of
man, oh my god, I wanted to make so many different tiles, but it took forever to make the tiles, and then like I had a really lazy map editor that took forever to like create the data sets, and my biggest strength is underestimating how long stuff takes to make. That's my number one strength or weakness, however you view it.
We can simply use the same possible states as before.
Yeah, those tiles are not enough. I wanted more tiles, way more tiles.
To this house that is built into a hill, feed it to the algorithm, and it will learn from our data set to generate a whole new type of house. I have no words. And of course, there's absolutely nothing stopping us from increasing.
Yeah, this time lapse that you're looking at, I think that this is like a few hours that it took to generate this. I just sped it up. Yeah, it's so cool.
Yo, y'all seeing this?
That's so cool. I just want to like be able to look at a map like that. That's like 2,000 by 2,000 with a bunch of different tiles. Like, oh, I just want to see it. I tried my hardest to make that happen for this video.
Dataset map took me some good hours to put together.
And that, I think that like something like that is like what quantum computing needs to promise, stuff like that. Like I understand the speed up benefits for like medicine and stuff like that, which would be an amazing application of the technology. But if it only has like a couple of use cases, I think it's gonna fall into like the realm of AI, which AI is kind of, that's so cool. AI is kind of in a weird spot right now where like it's really only good for like facial recognition or facial generation. Everything else is kind of like, what do you use AI for?
That's how long I have to wait every single time.
A quantum computer will be able to reduce this generation.
We need more tech that has like a variety of uses.
Seconds or minutes, like something you'd expect with Minecraft world generation. The only problem is, I tried
that would
for
be
a
so amazing.
solid week.
Yeah, I really tried. I really tried super hard.
Trying to turn this regular algorithm into a quantum
algorithm. I tried incredibly hard. I spent so much time. I think a couple of months on this.
I instead had to wait forever and generate those complex worlds on a regular computer. But I still believe that this is possible to do with the quantum computers that I.
Even with that said, it's like a couple of months with like cutting edge technology. That's nothing on the scale of like how many years the quantum computing researchers have been putting in to get us to this point.
The show had to go on. So.
And I wish them the very best with continuing to advance the field forward.
I am very excited about how
because anything that gives me faster speeds, I'm all down for, and you got my encouragement.
We probably should focus on that. And there's also quantum drug development that might save a lot of lives. But just imagine using a quantum computer.
Imagine this. Imagine.
Fortnite-sized map with all its detail at the click.
Do you know how many quantum computers you could sell? If this is like the promise,
give a huge thanks to Qiskit.
If the promise is that you can generate Fortnite-sized maps at the click of a button, do you know how many quantum computers that IBM or whoever else would sell? They'd be selling like, you don't even understand.
Shouts to all the quantum computing researchers out there. If you want to support me in this channel,
good deal.
Please go check out Qiskit's YouTube channel. There you can learn all.
Shouts to Qiskit. Thanks for collaborating with my channel.
And more resources.
I wish you guys all the best, and I think that's the end.